Dear friends, first of all I should thank my students Devargo Shom and Aditya Chauhan, MSc 2-year Economics at IIT Kanpur for helping me out and taking this video. Today's video is about which real analysis book to choose if you are a student of mathematics and or economics or even engineering. So which real analysis book to choose? I have a book with me for economics students. I would like to mention specifically because I am from the economics department. A book called book by Ken Binmore, Mathematical Analysis by Ken Binmore. I am writing it here on the board. It is one of the best books to learn mathematical analysis from. Ken Binmore was a very big game theorist at the London School of Economics. So, but if you go to any mathematics students or somebody who has studied mathematics, even he himself has or herself has studied the book or not or done anything with the book or not, they will tell you, you have to study Rudin, Principles of Mathematical Analysis. This is a baby Rudin. You know this book. This is nothing. This is the minimum you should know. People forget that there are many people who can't understand Rudin, in the so-called baby Rudin. There is a story associated with my own baby Rudin which was taken by my friends, and after many years, maybe 20-25 years or 30 years possibly, he writes to me that he has my book, and I told him that okay, please send it back. But it's in a very little bad shape, so I didn't show you here. So I had to buy another one. The problem with Rudin is that it starts with real and complex numbers and then goes immediately to basic topology. So without understanding real numbers, getting directly into topology is always not a very good feeling. So that might unnerve you. It might be a very natural approach to Rudin. It may not be the most natural approach to many of you. So the book that I suggest and is at the topmost of my list is the book by Bartley and Sherbert. This is the book I suggest both for economics students and for mathematics, those who are doing an honors degree in mathematics. Economics students who are at the master's level first year, they should definitely try to work through this book, because this book actually tells you what real numbers are. They don't jump into topological structures immediately. The topology of the real line is studied, but the word topology really isn't uttered. Here they start with preliminaries, real numbers, sequence and series, limits, continuous functions, differentiation, Riemann integral, sequence of functions, infinite series. The generalized Riemann integral is an additional thing, and glimpses into topology is at the very end. So what is in the very beginning of Rudin is at the very end of Bartley-Sherbert. So you have to know so many things to really come and have an appreciation of what topology is. So I would suggest that this book, which now has an Indian edition, which is published by Wiley India, for our region. So this is a book which is a must. So anybody who is seeing it from abroad, please understand that these books are not to be sold abroad. It's illegal to be sold in the US. Another book which can go as a companion to Bartley-Sherbert is Stephen Abbott's Understanding Analysis. Though this book is not recommended very much as a text in most courses, I will, because people are so people are so enamored with baby Rudin, but this book is very good because it has very good examples and starts in a very logical manner, takes time to develop things, and has a huge number of problems. And he also at the beginning talks about his fascination for Bartley and Sherbert. So here, you students out there who are being intimidated by the principles of mathematical analysis of Rudin, I would like to tell you that to begin to learn real analysis, you do not necessarily have to study Rudin. Even if some in mathematics who is a very big math guy will come and tell you, oh, if you don't know Rudin, what math you know? Because I remember when I joined the mathematics department here at IIT Kanpur, some of my colleagues who are from the Tata Institute of Fundamental Research would tell that, oh, you know, when I was doing my PhD in TFR, they used to ask, have you solved the whole book of Iron-Hurstein topics in algebra? And I would look at them. Yes, during my undergraduate days, I have seen Iron-Hurstein. I do have now a copy of it. But I haven't done problems of Hurstein. Maybe in one chapter I have done it. And they said, oh, you haven't done Iron-Hurstein's book. What the hell are you going to do? What maths are you going to do? But yeah, but that doesn't mean that I have not studied any group ring fields or anything, things like that, or algebraic structures, or Galois theory for the matter. I specifically like John Fraley's book. The first edition of John Fraley's book is just first or second edition which I had is just superb. It was published in India by Narosa Publishers, which I had. I'll show you and I'll solve some problems in the board in the next one. It was just too superb a book. And it was very fun reading. The questions were graded. There were a lot of true and false type questions, so you could have a lot of fun. So the questions came out and so difficult questions and little hints. So I found it much more comfortable. You learn a subject from which you are comfortable with. You don't learn a subject because the community of mathematicians decided that this is the book this is the Bible and you really have to go by that kind of holy scripture. This is the main book and you have to go by that. That's a very, very wrong approach. So I don't expect students to have this book. This is an actual Springer book which is costly. I expect institutes or universities or even colleges or departments to buy this book so that students can see them as a reference or have them online at least. Another book which is not published but published by the writer himself, a mathematician at the Department of Mathematics and Statistics at California State University in Sacramento, J. Cummings, has written this very big book. It's called Real Analysis, a long-form mathematics textbook. If you can have a hand on this would be my book for those who think they are very weak in real analysis. They are afraid of real analysis, even for the math student. And definitely I recommend this book for economics students because it goes very structurally, step by step. It tells you historical stories. And can you believe that there is a whole section on cardinality? And because with cardinality means what are the number of elements in a set? You actually go to the goal of solving what I would say. When you go to the goal of knowing about countability and uncountability. So it's a beautiful way of doing things. So you can see there's this whole chapter which I was very surprised that somebody have a chapter on cardinality because most books will give it on a chapter on sets. That he thought that cardinality is a very, very important thing. And this is called a long form because he writes a lot of proof step by step. The spaces are given nicely, it's easily readable. So I think this is a book which is worth looking into. And he does a lot of good examples and whatever you need in a course in real analysis, it's there. He even talks about measures of sets. He talks about Riemann integrability in a very stepwise way. So I really recommend this book. But for those students who feel that they are very, very weak, every good college, every good university in India at least should have 4 or 5 copies of this book. It doesn't cost much for a university to have this book because students who feel themselves completely daunted by Rudin, completely afraid of such books, will be very happy to have these books because the exercises are so nicely graded. The exercises are so nicely graded and you can actually do it step by step. They are so simple. From simple you go to a little difficult one, then little difficult one, and by the time your confidence increases. And he gives 2 or 3 open questions at the end which might spike your interest in the subject, and who knows, somebody who felt weak in mathematics might turn out to be a very big mathematician. So with this and these recommendations, I end my program today. I thank my students again, and with this I say a goodbye to you. Have a good evening, have a good night, and always think that mathematics is a subject of pleasure and it should never give you any pain. Thank you.